I know I'm the last person up, so I'll try to keep this fun and not bore you guys too much.
You're between us and alcohol.
Yeah, I know, it's true. I'll try to move this one along and keep you guys interested. So my name is Michael. I work for Amazon, and I have been there for a while. I've been there about 5 years. Worked in a couple different parts of the business. Started out on the operations side of things, and I led the Echo and the Echo Dot, and more recently now I lead CV for Alexa. So who here owns an Alexa device? Not bad, not bad. Who owns a device that has a camera in it, like the Echo Show? Is there anyone? Any takers for the Echo Show? No? So we do build Echo Show devices now that also have a camera in it. That's where the CV comes into play. And it is really interesting because most folks will think about Alexa as having ears with the microphones, but with the camera now we give her eyes as well. And so I'm going to be talking a little bit about how we're able to sense what that does for the larger vision for Alexa, and how the features that we build and the tools behind that, like neural edge processing, how that allows us to meet that vision. So Alexa's vision, many of you may have heard, she tries to be very helpful. She's your trusted assistant. Now she's also a friend, a companion. We try not to get too weird there, but we try to make her very useful. And the way that I do that, by leading CV and sensing, is through what we term ambient intelligence. And so that concept is that she should fade into the background. You don't need to even know that Alexa's there, but she's able to anticipate your needs and take actions based on that to help you. So I'm going to talk about a couple of those use cases in a bit and explain how we do that. But it's primarily with the eyes and the ears that I had mentioned before. So sensing that you're there, sensing potentially how you're feeling, what you need, and then taking action to help you or to make you more safe. So getting into why we're here, this is the AI Accelerator Summit. I want to talk about neural edge processing and what that means for Alexa and how we have started to build our own silicon. Now, that's not building silicon in the terms of having our own fab or anything like that, but this means that we've been making custom chipsets that do exactly what it is that we need. So in 2020, we launched the AZ1, which was our first foray into this. And the AZ1 was interesting because it allowed us to process speech recognition two times faster locally than we could before. And for Alexa, that's huge. So latency is a really big thing. We want to be able to comprehend, recognize what you're trying to say really, really fast, and then get you the information you need right away. So that was our big kind of first leap into this. Last year, we launched the AZ2, which took things a bit further and moved away from just the speech recognition stuff to also things like facial recognition and processing CV models locally. The number here that really jumps out is that the AZ2, this is only 1 year apart, is 22 times faster than the AZ1. So huge difference. The AZ1 was just kind of like dipping our toe in the pond. The AZ2 was maybe like a full foot, and hopefully we keep moving the needle there, which I'm sure we will. So this is the sort of core core technology that powers a lot of these sensing models that we have launched. So I want to talk a little bit about what those models and features are and what the customer benefit is. Since this is Amazon, we always work backwards from the customer. Sean this morning talked a little bit about that. They'll go into some detail there in a bit. But these are 3 features that I have launched. Visual ID is our version of facial recognition. We can recognize you, and then we personalize the content so that it's tailored for you. So most folks who have an Echo device in their home don't live alone. They have a husband, a wife, a partner, kids, roommates, and being able to personalize the content makes Alexa more relevant. So if you have calendar events, reminders, notes, news articles you like, we're able to show that to you when you are in front of the Alexa device. Occupancy routines is one that uses both CV for the devices that have a camera, and for the devices that don't, we use ultrasound motion detection. So this is really interesting, where we emit ultrasonic waves out of a regular Echo device, and then the microphones on device are highly sensitive and pick up the signal back. And so it's constantly emitting this wave, and whenever a person or an object moves in that range, we have a machine learning algorithm that runs on the AZ2 that will process that locally really, really fast and determine whether there was motion in the room. And we can do things like rule out repetitive motion from a fan, because at the end of the day, we don't care if there's a fan blowing. You don't need to be told that there's a fan or to have lights turning on when there's a fan there. You want the lights to turn on when there's a person there. So the machine learning algorithm that runs on device is able to cancel out anything that is not human motion. And it's not perfect, but it does a pretty good job. And then lastly, we have smart motion. This one is really interesting. This is only on the Echo Show 10, and we're able to move the display when we hear someone or see someone who is engaging with the device. So if you call Alexa, we use sound source localization to find where you are, and then the camera takes over and locks in, okay, that's a person talking to me. And this is really useful if you're on a video call and you're moving about the kitchen or the living room. We can keep you in the field of view. Or if you're following along to a recipe while you're cooking and you're going from the stovetop to the countertop to the table, the whole time you're able to keep in the field of view and see what's on the display. So these are just a few features that we have launched that have really added some value for customers, and they all run locally on either the AZ1 or the AZ2. So, like I had promised, I want to talk a little bit about how we actually build these features and the process we go through in coming up with what the customer experience will be, setting a vision, and then turning that into a set of detailed requirements that the engineering team can go and build. So for most of these features, we use some set of sensing KPIs like a false reject rate, false accept rate. Sometimes it can be precision or recall. It depends on the feature. For visual ID, there is a miss ID. So if you have a brother who looks like you and we think that he is you, we messed up. And so we track that, we measure that in the lab, and then we also are able to collect feedback on that and iterate and train the model to do much better than we had originally. That was a huge pain point, by the way. Latency is one that applies to all the features. I talked about this a bit before. This is where that local processing, the neural edge processing is huge. It brings down latency and allows us to deliver an action really, really fast. Range, how far can Alexa see or hear before she takes an action to help you. And then privacy requirements. Certain features, especially with a camera, it's really important that we keep all the images on device. We don't want to send your biometrics to the cloud. Even though it's going to be safe there, there's a perception that Amazon has your biometrics, your images, and Big Brother can do whatever they want with that. That's not how things actually work, but we want to make sure that there's not even the option of that, and we process and store this all on device. Again, thanks to the AZ2 in this case. So all that is good, that's nice, that's great. We have this list of requirements that normally I'm the one who comes up with that, and then I say, hey, team, let's go and build this, and they say, that's not going to be possible, and here's why. And it's either because of the hardware or schedule constraints or cost. But in looking through the hardware constraints, are we building this on a device that has already launched and is in the field? If so, then you can't influence the hardware. You have to make do and find a way around that. Or is this a new device that you have the time to help influence the processing power, how much memory is on device, what kind of camera it is? This is all really important. If we're launching a security feature, the camera needs to be able to see in the dark. Otherwise, it's not going to be a very good feature if someone breaks in at night and the camera can't tell that anyone's there. So all of that is going to be very, very dependent on the use cases that I had talked about before and the vision that has to be clearly articulated. And then lastly, if you are going to add hardware for your feature, you have to be able to back up that it's worth it. So all of these things add cost, that's real dollars to your BOM. And you have to be able to show with data that it's worth it, that you're going to either sell more devices, that you can charge a higher price, that there's a new monetization stream that may result from this. All of that is really, really important. And it's not easy, let me tell you. Schedule is number 2 here. So at Amazon, time to market is really important. We try to get things out there fast, learn from the customer, see what they have to say about things, iterate, and then either we double down if we think a bet is working, or we cut our losses and we pivot and focus on something else. But the only way we can do that is by getting things out there really fast. And so as we're going through that, if you're building custom silicon, which has a really, really long lead time, it makes things difficult. So you have to have the foresight and the planning to intersect that custom silicon with either a device that is coming out in a couple years, and then have that foresight to know where the market is going to be then, and be able to kind of think multiple years ahead. Also not easy. These other long poles, most of you are probably aware, but custom silicon is probably the longest of these long poles. But data collection for a model, that's going to take time. You have to then train the data, train the model with your data. All of that will take time. Integrating it onto the device, and then testing through alpha and beta. This is one that applies quite a bit here for the custom silicon, and that's cloud versus edge. If you have custom silicon that can really handle a lot of the processing, that's all going to be done on the edge. But as you start to launch more features, you have to consider, is there a balance here between edge and the cloud. And the cloud is great because you can run a lot more computationally heavy models up there, but you're going to have longer latency and you lose that privacy messaging that we had talked about earlier. So again, each feature is going to really sort of lend itself to whether it can be a cloud model or not. If it's high privacy feature, probably can't be. If you're trying to detect a pet in the home, there's probably a lower bar there than if you're doing facial recognition. So all of that has to be looked at, and it's going to be really on a feature by feature basis. Trade-offs. This is where a product manager actually earns their salary, or at least tries to. Trade-offs it's a really important part of the business. You can't have it all. And so you have to look at things like performance of the model versus the cost of adding more memory, more compute, the cost of the custom silicon, how long this will take you, if you're going to wait multiple years, or if you can go with a chipset that is already on the market that maybe costs a little bit more or maybe isn't quite as power efficient, or whatever the case is. And then of course, privacy, like I had talked about before as well. And there's so many different vectors here that you have to look at. It's going to be very, very feature dependent. I can add a little bit about visual ID. So this was one where we do not send the images off the device ever. And you may think, okay, that's great, like that's a good privacy message, but there are some clear downsides with that. If a customer has multiple Echo Show devices and they want to use visual ID on both of those devices, they have to enroll multiple times. And that's friction that a lot of people wouldn't get. And like, why would I need to do that if I've already enrolled my face once? It's broken, it's not working. When in reality, they just don't really know that. And that's on us, that's on me to figure out a way to make that easier for them. But that was a conscious choice to really lean into the privacy messaging. And it was well received by the press, but we have gotten some feedback that customers don't really know why it doesn't work and all this other stuff. And so that's when we start looking at things like, can we send it over the local network? Are there sort of hub models that we can use, where we distribute the compute across your home? So these are all interesting things we're looking at and trying to find ways to solve these pain points for customers while maintaining a privacy promise. So I want to leave you with this view about ambient computing, or as we call it, ambient intelligence. So 5 years ago, Walt Mossberg, famous tech press guy, used to write for the Journal and then Verge a little bit later. His last column, he wrote, "Tech was once always in your way. Soon it will be almost invisible." That's our goal. We want everything to just happen in the background. You don't even have to think about it. Whenever you have an issue, a problem, Alexa has already found a way to help you, whether that means you're walking in a room and it's dark and the lights go on, whether it means you're too hot, she turns down the heat in the home. There are so many examples. I won't get into everything without giving away too much of what we're trying to do. But it's through neural edge processing, through this custom silicon with the AZ1 and 2, and a lot of these interesting features that we have launched, that we're getting closer to making that vision a reality. So it's really interesting time, and it's a place where I think in another 5 years we're going to be much closer than we are today. Thank you.
So how much data, what kind of data is stored, and for how long is it stored on that device?
So on the device, I'll talk about Visual ID since I know that one the best. I don't know all the other stuff in as much detail. But on Visual ID, when you enroll your face, we store the vectors of your face. And so that gets stored as a numerical sequence on the device. Whenever a person walks in the field of view, we attempt to recognize and match the vectors with what is stored on the device. We don't save any of those recognized or not recognized pictures on the device. We try to match it. If it's a match, then we send it along and say, okay, Michael is there, but then we get rid of the image. We don't keep the image on device. We don't send it anywhere else. So the only images that are actually stored on device are the first ones when you enroll, and that's it. And we try to have that kind of mental model for all of our features so that we're trying to store as little as possible, both from a privacy point of view, but also because it takes up memory on device, and we don't want to do that either. So it does help us as well. Yes?
How much of a problem was power consumption with this new basic chip? How do you overcome that if you were the better?
Yeah, so that was one of the key reasons to do the AZ1 in the first place, was because it was a much more power efficient chipset. And so we're really big on reducing power. We have what's known as low power mode, where we kind of shut down a lot of the cores and turn off certain features when we think that no one is there. The AZ1 allowed us to do a lot of that. So it was actually 85%, or I'm sorry, I don't remember the exact percentage for power savings, but it was a pretty significant reduction. And so the custom silicon has helped us to reduce power, not the other way around. Yeah. Yes?
Are you just inference, or are you also thinking about training for the AZ class?
Good question. So I'm not sure the answer, actually. I think so. The models that we have, there are lots of different ways that we train them, and so it's kind of less important that is done on the silicon, for us at least, but it's probably something that the team is looking into. I'm not personally sure, though. Yeah. Any other questions? Yeah.
It's not a technical question, but I'm not a big fan of the Alexa yet.
That's fair.
Okay. Do you guys have any, the visual ID that I started today? The visual ID, do you have any plan to implement for your pet recognition or something like that? I know that the Alexa cannot recognize the dog's barking or something.
That's right.
Maybe not.
Yeah. So right now, there are what we call acoustic event detectors that can pick up certain sounds, like the dog barking, and then take an action based on that. I can't really talk about what we're working on that has not launched, but we're thinking about lots of different things and trying to make all of the ambient intelligence, that whole vision, whether that's CV, microphones, other sensors, we're trying to make that better. So we're definitely thinking about lots of different things. Yes.
So there was a lot of talk on like the vision aspect of the face detection. Is there a similar thing on the voice side?
Yes.
Okay. Because one of the things that one of the weird use cases or edge cases I've seen is like a kid says add chocolate to the shopping list, and you don't necessarily know which person added what
Right.
to what list.
Yeah. No, that's a great point, and it was a major pain point. Like there was this news article a couple years back where a kid had bought like thousands of dollars worth of things on the Alexa account. So like we had to figure out a way to mitigate that so that doesn't happen again. So there's Voice ID as well, where people can register or enroll their voice, and they just have to say like a couple sentences, and then Alexa knows whose voice it is, and then you can put limits on a certain profile. So if it's a kid, you can limit the kid so that they can't shop, they can't ask certain things, they can't use certain games or whatever it is, and you can also do that with visual ID. So you can say that this is a kid's profile if they're recognized don't show certain content. So that is available now. Yeah. Yes.
With Alexa building all these new capabilities and functions, do you guys see like an increase in possibilities for like third-party developers to come and build different apps or games within the platform?
Yeah. So we do have the Alexa skills kit and skills store, where there are tens of thousands of different sort of apps out there that you can use. It hasn't really taken off in the same way as say like the Apple App Store, but the idea is pretty similar, where we open up certain things to third parties so that they can develop. And there are some that have done really well. There was the Jeopardy game that for a while was really popular, where you could play Jeopardy on Alexa. There's these kind of various white noise skills that you can use at night, and there's a way for them to also monetize that too. So yes, we do have that. One more.
Do you plan on commercializing the AEC for use in other integrated projects? Kind of like a Quirrell CPU?
Yeah, not that I'm aware of. I don't think there are any, or I don't know of any plans for that.
Any final questions?
One more.
So I know that most of the Alexa use case right now is like ask a question, get an answer, give an instruction, get it back. How important in your list of priorities is sort of context to being able to change a conversation on Alexa?
Hugely important. Hugely important. We put a lot of resources into that. It's called natural turn taking. There's a lot that we're doing to try and make it more natural. Right now, it's not very natural. You would never have a conversation like that. So, and the context part is really key to that as well. If you ask a question and then you ask something else a minute later, there's a high likelihood that it's going to be related. And so having the context there will make Alexa more useful. So there's a lot of work that we're trying to do to make that better. I think we still have a long way to go, but it's a really hard problem to get right. And I know that we've already made leaps and bounds from where we were a couple years ago, and I think we're going to keep making things much better.
I know it's been important for a while, but is sort of a horizon anywhere close by? Like now, is there a line of sight to how long it can take? Is it a year, a few years, decades?
I can't really say for sure. I just know that we've come a really long way. I think we're getting closer, and there's a lot of things that we're doing. I can't really talk about all of them here, but there are lots of things we're doing that should make that more natural. Like one thing that we have launched is called conversation mode, where you can say, Alexa, start the conversation, and then you don't have to use use the wake word anymore, and you just have like a back and forth. But it's not very easy to set up. Most people don't even know about it. So there's a lot that we have to do there, but that's kind of like a basic building block that we have already shown can work. And I think we're going to keep making that much better over the years or months, hopefully. Yeah. All right. Sounds good. Well, thanks, everyone. Appreciate your time.